Hi, in this lesson, we're going to learn how to develop algorithms using strings. These are the major string methods that we covered in Unit 2. Let's review substring on the next few slides, since it will be very useful in our programs, and we can introduce a new method that can be even more useful. The substring method returns a string starting at index from and ending at index 2 minus 1. In this example, substring 03 of good day would return the value GOO. Let's do a practice problem refresher. What would be the output for this program? The correct output here would be E. Did you get that correct? Let's break down how we got this answer. Recall that each character occupies a specific place in the string, which is called the index. The letter C is at index 0. The second letter O is at index 1. The letter D is at index 2, and so on. The index will help us to access different parts of any string. The call to substring 3, 4 is isolating the string from index 3 to index 4. So for this method call using substring, the index 3 is included and the index 4 is excluded. So, a string identical to the single element substring at position index can be created by calling substring index, index plus 1. The substring method is particularly useful when attempting to traverse strings. Traversing is the process of going through a string one character at a time, often using loops. Here's an example of a string traversal using a for loop. Let's break this down. We initialize the for loop with the variable I set to 0. We set the increment to be I++. If we want to access each individual character in the string, we want the value of I to increase by 1 each time it goes through the for loop, so we can access each character at the next index. We next set the Boolean condition to I is less than print.length. If I is increasing by 1 each time through the loop, we want it to stop when we get all the way through the string. We set the Boolean to less than print.length because we want I to stop iterating through the loop at the last index of the string. Print.length evaluates to 9, the total number of characters in the string print. But strings start at index 0. As a result, this string only goes to index 8. If we want to ensure that this program ends at the end of the string, we need to set I is less than print.length. So the highest value of I that's included is 8. Now that we've broken down the for loop, let's take a look at the code that we've implemented in the for loop. Because this for loop is meant to print each character individually, we need to isolate each character in the string as part of this traversal. To do so, we can write substring I, I plus 1. Remember that substring from, 2 is inclusive of from and exclusive of 2. The call I, I plus 1 will include I and exclude I plus 1, isolating the character at index I. By isolating each individual character at index I, we can print each character individually. Let's see this in action. I is first initialized with the value 0. Then I is checked against the Boolean expression. In this case, because print.length equals 9, I is less than 9. The for loop then is executed. In this case, the print.substring I, I plus 1 is returned to the print statement. Because I is 0, the actual value returned is the result of substring 0, 1. The character at index 0 is P, which is then printed on the screen. The for loop then returns to the increment, which increases the value of I by 1. Then I is checked against the Boolean expression. In this case, because print.length equals 9, I is less than 9. The for loop then is executed. In this case, the print.substring I, plus 1 is returned to the print statement. Because I is 1, the actual value returned is the result of substring 1, 2. The character at index 1 is R, which is then printed on the screen. This is repeated again and again until I reaches the end of the string. and the value of I is equal to the length of the string. If we were to make I is less than or equal to print.length, we would get an index out of bounds error because we are attempting to access a string index that does not exist for this particular string. Generally speaking, we can traverse strings using this formula, where the string character is equal to the substring I, plus 1 on each iteration through the for loop. We can use this formula to manipulate strings in a variety of ways. Something to note is that we can simplify this general formula by using the char@ int index that we learned in Unit 2. We can use the method char@ to access a specific character in a string. In this case, if we write stir.char@1, we are asking the program to return the character at that specific index. In this case, E is the character found at index 1. We can replace the substring I, plus 1 with char@I in our general formula as well. Note that the char@ method returns a char value, not a string value. It's also important to know that char@ is not tested on the AP exam. For the purpose of this exam, you should know that substring performs the same function and use that. Traversing through strings is particularly useful when trying to create modifications to strings. We can create many helpful methods that allow us to manipulate strings however we see fit. For example, we can use string traversals to determine how many characters in a string are uppercase. Here is an implementation of a method, num uppercase, that returns the number of characters in a string that are uppercase. The for loop in this method iterates through each character through the string by assigning the char character the character at index I. If the character at index I is uppercase, the counter adds 1 to the count. Otherwise, the counter does nothing. The counter then is returned to the initial program. We can also use traversals to replace substrings with other substrings. Here we have implemented a method called replace that takes a string and replaces string remove with string add at every instance it occurs in the string. Let's explore the method a bit. Because strings are immutable, we can't just change the values of the substrings within an existing string. Instead, we can create a new string that holds the characters we want. In this case, we can create a string that is empty by writing open quote, close quote as the assigned value. Like in the last method, we iterate through the existing string and get each character, this time using the substring method. If the character is equal to the value of the string that we are intending to remove, then we replace that value with the character we want to add. We do so by simply adding the string add to new string instead of adding the character. If the character is not equal to the substring we want to remove, then we add that character to the new string. This way, all of the characters that we want in the string will appear, and those that we want to replace will be using the if statement. Here is an example call to the replace method. In this example, we initialize the string altered string to be the return value of replace, where the value p is being replaced with the value st. As we can see in the print statement, all instances of p have been replaced with st. The initial p does not change because p and capital P are different characters. We can create the same method using a while loop. Strings can also be traversed through while loops. In this implementation, the while loop is checking to see if the substring that is being removed can still be found in the string. Index of returns a positive integer or 0, indicating the index of the substring if it exists, and -1 if the index cannot be found, which is why it is set to greater than or equal to 0. The next line of code takes the initial string that is input into the method and changes its initialization through concatenation. Using the index that the substring remove was found at, we can create a new string by adding the new value in the same index that the removed substring belongs to. We can do that by taking the substring before the index, 0, index, and the substring after, index plus 1, and add the new value in between those two substrings. This changes the assignment of string and keeps it updated before it is returned. Let's take a look at this method in action. As you can see, there are some print statements to help make some sense of how the substrings are being concatenated. We can see that each time through the while loop, we are finding the index of the next value of p, and then replacing that specific index with the replacement substring st. Each time through the loop, the original string is altered through concatenation, allowing the index of call to progress through the string and replace subsequent values of the substring being removed. Now that we've got a better sense of how traversals work with strings, let's try a challenge problem. Let's create a method that reverses the order of a string. For example, if we had the string hello world, calling reverse on hello world would result in the string backwards. Pause the video to try to think of how we might implement this method using some of the traversal tools we learned earlier. We can actually create this method in 6 steps. First, we need to create a method signature. Then we can create a new string that we will return with the reversed string values. Next, we will create a for loop to traverse through the string, access the last index of that string, and add that index to the new string. Finally, we will return the new string to the program. Let's build this out. First, we create a method signature. The formal parameter for our method should be the string that we would like to reverse. Next, we create the string newString that will be used to create the reversed string. Remember that strings are immutable, so we can only manipulate them by creating new ones or reassigning them to new values. Next, we need to create a for loop. Before we do that, we should think about what this loop needs to look for. In order to create this new reversed string, we need to access the last index of the original string and traverse the string backwards until we get to the first value. Before moving on, can you think of a way we can manipulate the for loop so it can achieve this? Here is an implementation of the for loop that we just discussed. It looks a little different than the one that we originally used to traverse strings, so let's break it down. Instead of initializing I to the first value of the string, we want to initialize it with the last value of the string. We can do that by calling string.length -1 to get the last index as the first value of I. Remember that the length of a string is 1 more than the last index, because strings start at index 0. We then set the increment to a decrement of 1, so each time through the for loop, the value of I decreases by 1, and the index of the string is 1 less. Once I is less than 0, the for loop stops, as we've gone through all of the indices of the string. Just as before, we want the individual characters from the string, so we can call substring I, I plus 1. We then add the character to the string newString. This way, newString starts with the last character of the original string and ends with index 0 of the original. Finally, we can return the new string to the program, which should be a fully reversed string after the for loop is over. Here's a live demo of that method. Now that you've learned about developing methods using strings, let's get some practice developing them in the CodeHS editor.